Thank you for the opportunity to present. The title of my study is Research, Science, and Knowledge, the demarcation question revisited. My name is Q.G. Yao, a professor of communication and media at Lamar University in Beaumont, Texas. Imagine you were teaching a pre-Copernicus geocentric time and testing students. The Earth is at the center of the universe. Students answered, true. Would you grade that answer as correct or incorrect? We all know how that answer should be graded then. No matter how incorrect it is now. But can we identify any major assumptions true for now, but maybe untrue in the future? It can be any assumption. For instance, I have been thinking of Einstein's concept of space-time as mixing the physical object space with the conceptual object time, mistaking clock running as an accurate measure of time in all situations and leading to the incorrect idea of time travel. So that means we cannot have the truth with a capital T, as Richard Rorty said in 1972, nor even our error from it. The inaccessibility of the truth with a capital T to us is described in a study I presented last year based on Popper's three-word theory. Word one is the reality or the world of physical objects. Word two is the individual's mental processing. And word three is the public knowledge shared and archived in the form of communications and located in libraries, universities, museums, etc. Popper called objective knowledge because it is independent of individual thinking. For individuals to observe or interact with words one or three, two barriers have to be gotten through, but never really gotten across: perception and language. What's more, for individuals to observe or interact with word one, they must go through word three, in many cases, without knowing, creating the issue of value latentness. Positivists study word one or three without considering the intervention of word three, perception, and language. Phenomenologists notice the intervention of perception but ignore the language barrier. Interprevists realize the interference of language but are less interested in words one or even three. Individuals can make change in word one through physical intervention, verifying the content in words two or three. They can also pull content in word three through education and learning, or contribute to it through dialogue, discourse, negotiation, and peer review processes. Both words two and three are results of mental activities and follow the mechanism of conceptualization and the three laws of thinking, which keep words one objects in a separated and a still situation for mental processing, thus creating more errors. So, how is knowledge exactly defined? Webster's dictionary defines it as information, understanding, or skill gained from experience, education, science, art, or technique. Collins' dictionary defines it as information and understanding about a subject. Those definitions seemingly include all types of information or understanding. Philosophers have stricter definitions. Plato's JTB theory of knowledge holds it to be a justified true belief, which was popular for thousands of years and until the contemporary era, and then expanded to the JTB plus X theory, adding a fourth condition to solve the Gettier problem and rule out the possibility of gaining knowledge with just luck and no understanding of the underlying mechanism. This sounds more like research. What is research? Webster defines research in two ways. A noun meaning studious inquiry or examination, and a verb meaning to study or investigate carefully. Collins defines research as a noun meaning work that involves studying something and trying to discover facts about it, and a verb meaning to try to discover facts about something. In my presentation last year, I defined research as the critical process to generate knowledge through logic reasoning, which can be conducted through different methodological approaches: positivism, post-positivism, phenomenological, interpretism, theoretical analysis, which means cultural studies, critical studies, feminist studies, especially logic, mathematics, legal analysis, etc. Then, what's science? Webster defines science as knowledge or a system of knowledge covering general truths or the operation of general laws. Collins defines science as the systematic study of the nature and behavior of natural things and the knowledge obtained from the study. If we cannot know the truth, which is a capital T, can we then still work on science? Philosophers of science have defined science too. Positivists, represented by the Vienna Circle and literally Rudolf Carnap, believed that science should be verifiable or confirmable, which is also how they demarcate science and nonscience, mainly matter physics, but also pseudosciences like alchemy. Along this line of thinking, Robert Merton also proposed the four criteria of science: universalism, communism, disinterestedness, and organized skepticism. Karl Popper and his followers, however, attacked positivism on two things. First, theories or universal statements cannot be proven, verified, or even confirmed, particularly when the future is considered. Second, the typical form of positivism hypothesis testing, if P then Q, Q then P, is a logical fallacy. Popper then established his own criteria for science, falsification, which has been cited by a US court. Because it is so easy to find counter evidence and falsify useful theory, Popper's student, Emery Lakatos, proposed the sophisticated methodological falsification against not a single theory, but a network of theories, a program. Popper classifies astrology, psychoanalysis, both Freudian and Aldrin, and the Marxist theory of history as pseudoscience. Lakatos classifies degenerating programs that are unable to predict novel facts, but only rely on ad hoc theoretical adjustment as pseudoscience, and progressive programs that can produce corroborated predictions about novel facts as science. The falsification idea has also been challenged by several schools of scholars. Feyerabend argues that Popper's falsification is limited to testing commensurable theories because it relies on deduction of hypotheses from incompatible rivals. The Duhem-Quine thesis holds that it is impossible to test or falsify a hypothesis independently without a web of belief. Kuhn and Yao pointed out that few researchers practice falsification. Feyerabend proposed an anarchy of science, calling for the ruling out of the approach to establish one single scientific method or expert dictation, so that anything goes. There's no pseudo-science, and his claim clearly is against common sense. Thomas Kuhn's scientific revolutions describe science in normal times as solving puzzles as gaps between accepted fundamental theories after one scientific revolution and before another, like astronomy. The demarcation is then that pseudoscience does not solve such puzzles, like astrology. Kuhn has declared himself to be a historian, not a philosopher of science, suggesting that he is just describing scientific activities, including science's social and political components, instead of proposing a norm. This review of historical search revealed several key characteristics. The first characteristic is usefulness. When the loss of the truth with a capital T makes truthfulness elusive. Usefulness means how useful the theory is for our existence, physically or socially, and cross-sectionally or longitudinally. Usefulness instead of truthfulness is the primary criteria for adopting science. For instance, heliocentrism was proposed in 5 BC by Greek philosopher Philolaus, established in 1543 by Nicolaus Copernicus, but widely adopted long after that when it was really useful in scientific activities like a calendar calculation. Usefulness instead of accuracy is the primary criteria of our measurement. We always measure things as usefully, but rarely as accurately as we can. Usefulness instead of consistency is the principal criteria for mathematical development. This can be seen in several examples. First, negative numbers. When negative numbers were first proposed, several prominent thinkers found it inconsistent with the existing mathematical system. Blaise Pascal wrote, I have known those who could not understand that to take 4 from 0 leaves 0. Anthony Arnold pointed out the absurdity to have 1 over negative 1 equals negative 1 over 1, equating the ratio of a large number over a smaller number to the ratio of a smaller number over a large number. Negative numbers, however, were still adopted for their usefulness. Second, Russell's paradox, which asks, imagine a set that contains all sets that do not contain themselves. Does this set contain itself? The paradox demonstrates the mathematical inconsistency and caused the third mathematical crisis. After multiple failures to solve it, mathematicians made arbitrary rules to prevent such sets. Third, mathematics is learned, not a priori. Different cultures developed different mathematical or measurement units and medical or calendar systems, and slowly switched to the most useful ones during cultural exchange. The number 0, for instance, was invented by ancient India and brought to China by a third-generation Indian Chinese astronomist, Gautama Siddha, in the early 700s. It was not really adopted until the 1990s when Western science was popular and made 0 indispensable in daily calculations. The second characteristic is mathematical application. Science uses the best form of logic, mathematical measurements and analysis, encompassing both verification and falsification of middle range. In addition, Science must have replicability and generalizability, which implies methodological unity. Social science needs no method different from natural science. It is just harder in measuring man functions and particularly reflectivity. The surge of Gen AI evidences that man functions can be measured and analyzed and duplicated by machines. So, science is different than nonsense in that science is useful, replicable, generalizable, and supported by existing knowledge and mathematical calculations. Pseudoscience claims to be or takes the form of science, but has no such characteristics. A less feasible or very bold scientific plan is not pseudo-scientific. The latest Sir Isaac Newton's study of alchemy to find the active principles used to influence matter could still be scientific. If he claimed to have found them without evidence, however, would then be pseudoscientific. The demarcation, however, is not always the dichotomous yes or no. Alchemy has cultivated science. Science inevitably contains false elements. Newton's theory of relativity was used to be science, but is nowadays termed as pseudo-scientific. There are always special situations. For instance, Newton's relativity and Ramanujan's theorems may have been driven by more inspiration than logical reasoning. The initial proposal of the theories of evolution, continental drift, later plate tectonics, and the Big Bang may have involved less mathematical application, but usefulness, mathematical application, replicability, and generalizability are the major characteristics science shares today. Finally, I'd like to share a point of mine on the overall view of research in science as the discussion of this study. The indistinct universe is categorized by cognition, slicing concepts into the knowledge structure like creating specimens. Research engages reasoning and sense quantification. The verified plus the unverified forces to shape causations. Theories are thoughts useful for our existence, and absurd claims result from the imbalance of reasoning and verifications. Being useful and being believed demand opportunities. The theory being more useful, we say, is stronger in validation. Thank you for your time and listening.